This video is part 2 of Factoring Notes Day 2. We started this last time and now we're going to finish the notes today. Now what we ended on last time was cubes. And cubes, those numbers were 1, 8, 27, 64, 125. But now we're going to switch to squares. And squares, these are the ones you knew first. 1, 4, 9, 16, 25, 64, we could keep going. So those are the numbers we're looking for now. Now with all of these patterns, doesn't matter which one it is, we always want to look first to see if there's a greatest common factor. So when I look at number 1, there's no greatest common factor. So I see that it's a binomial. So with binomials, I can either do squares or cubes, but the exponents are even, so we're going to do squares. Now the difference of squares pattern for the first 3, you know this, we've practiced it and we've done it this year. So it's a binomial. I can take the square root of everything, so I'm going to go straight to my 2 parentheses. The square root of x squared is x, the square root of 4 is 2, 1 is a plus, 1 is a minus. We are done. On number 2, it is a binomial. There's a minus sign, and I can take the square root of both, so I'm going to go straight to my 2 parentheses. The square root of 9x squared is 3x. The square root of 16y squared is 4y. 1 is a plus, 1 is a minus. Now in number 3, you're thinking, I can't take the square root of all that. But you need to keep remembering, you've got to look for the greatest common factor first, which in this case is 3. So I'm going to take out a 3. Now I'm only taking out a number, so it's not going to change my variables. So 27 divided by 3 is 9, so I have 9a squared, minus 75 divided by 3 is 25, so I have 25b squared. In the parentheses, it's now a binomial, and I can take the square root of both. So now I can use my pattern. So the 3 comes straight down. I'll go straight to my 2 parentheses. The square root of 9a squared is 3a. The square root of 25b squared is 5b. 1's a plus, 1's a minus, and we're done. Number 4. Now we haven't dealt with one like number 4 before. We know we can take the square root of 25, but we don't know about x to the 6th. When we are doing cubes, we wanted to see if we could divide the exponent by 3. When we're doing squares, we know we can take the square root if we can divide the exponent by 2. So 6 divided by 2 is, whoops, not 6, that's crazy, is 3. So I'm going to go straight to my 2 parentheses, and the square root of x to the 6 is x cubed. Square root of 25 is 5. 1's plus, 1's minus. Now, when we have these problems, when the exponent of the x is not the invisible 1 like it is up here, all these have the invisible 1, right? All here, then our final answer. They have invisible 1. We can just stop. But here, it's got a 3, so we need to see if it goes further. Well, if it's 3, it doesn't work for the squared pattern, but it does work for the cube pattern. However, we cannot take the cube root of 5, so we know we can't go any further. We're done. All right. On the next one, it's a binomial. There's a minus sign. I can take the square root of both. The square root of x to the 8th, well, I'm going to do 8 divided by 8 divided by 2, which is 4, so I have to get x to the 4th and x to the 4th. The square root of 36y squared is 6y to the 3rd, because 6 divided by 2 is 3. 1's a plus, 1's a minus. Now to see if that goes any further, we'll look at it. But I can't take the square root or the cube root of all of something, so it's not going to go any further. Now, what am I talking about where it might go further? Let's take a look at number 6. This is a binomial. I can take the square root of both, so I'm going to go straight to my 2 parentheses. So I have x squared and x squared. The square root of 1 is 1, so I have 1 and 1. 1's a plus, 1's a minus. But I've got this exponent of a 2, so there's the potential that it could factor further. And I can take the square root of everything, and we have the difference of squares and the difference of sums. So let's look at this. This one factors to x plus 1, x minus 1, because I took the square root of everything. But this one started with a plus sign. So because it started with a plus sign, I have x plus 1, x minus 1, but I've got to add the I, because remember, when it's a plus sign, we add the I. Okay, number 7. When we start number 7, This is one that gets flagged, and it gets flagged because the leading coefficient is negative. Anytime the leading coefficient is negative, you know you have to factor out at least a -1, if not more. But on this one, we can take out more than a -1. We can take out a -3. Okay, now I didn't take out variables, so my variables aren't going to change, just my numbers. So -3 divided by -3 is +1, but I don't have to write that. I'll just write x squared. And 48 divided by -3 is -16. Okay, now in the parentheses I have a binomial, so I'm going to go straight to my 2 parentheses because I can take the square root of everything. The square root of x squared is x, the square root of 16 is 4, 1's plus, 1's minus. Number 8, it's a binomial, there's a minus sign, but I can't take the square root of anything, so there's probably going to be a greatest common factor. Well, in this one I can take out a 5, I can also take out an x, and I can take out a y. Now this time my greatest common factor has numbers and variables, so everything is going to be affected by it. 5 divided by 5 is 1, but I don't need to write the 1 unless there are no variables, but we do have variables. There's 5 x's and we took away 1, so we have x to the 4th and the y's cancel. Minus 20 divided by 5 is 4, the x's cancel, and I'm left with 6 y's. Here, I can take the square root of everything. So I'm going to go straight to my 2 parentheses. The square root of x to the 4th is x squared and x squared. The square root of 4y to the 6th is 2y to the 3rd. 1's a plus, 1's a minus. Now I could see if it can factor further, but I can't take the square root of everything, and I can't take the cube root of everything. So there's no way I can go further, so I know that I'm done. All right, the next pattern is trinomials with a leading coefficient of 1. When you were in Algebra 1, they referred to these as green light. They were green light because you didn't need to stop and do anything else first. You just went straight to your answer. So I have a trinomial, and I mean the leading coefficient of 1 because there's no number out there except the invisible 1. So when that happens, I can go straight to my 2 parentheses. I have an x and an x. I'm looking for 2 numbers that multiply to 42 and add to -13. Because they multiply to a positive, they both have to have the same sign. Because they add to a negative, they both must be negative, so I'm going to say -6 and -7. We're not solving anything in these problems, so we just stop right here at the factoring. Number 2, it's a trinomial, leading coefficient of 1. I'm going to go straight to my 2 parentheses. I'm looking for 2 numbers that multiply to 28 and add to -11, and those numbers would be -7 and -4. Done. Number 3, I see a negative leading coefficient. That's the red flag waving around telling you take out a greatest common factor. Well, I can take out a -2. Now, I'm not changing the variables, so they're going to stay the same, but the numbers change. -2 divided by -2 is 1, but I don't have to write it if I have variables there, so I just have 1x squared. 10 divided by -2 is -5x, and 12 divided by -2 is -6. Now, in the parentheses, I have a trinomial with a leading coefficient of 1, so I'm going to go straight to my 2 parentheses. I have an x and an x. Now I need 2 numbers that multiply to -6 and add to -5, which would be -6 and +1. -2 and -3 don't work in this situation because they don't multiply to a -6. All right, next one, number 4. Well, it's a trinomial, and the leading coefficient is 1, so it's got to be a green light. I'm going to go straight to my 2 parentheses, and normally I'd put x and x, but x and x, that multiplies back together to x squared. I need it to multiply back together to x to the 4th, so instead of x and x, I'm going to have x squared and x squared. Now I'm looking for 2 numbers that multiply to -132 and add to -1, and those 2 numbers would be -12 and +11. Now my exponent is something other than invisible 1. It's a 2, so I have to check to see if it would go further. Well, if it's 2, it's got to be the difference of squares because cubes won't work, but I can't take the square root of 12 and 11, so this one stops. I can't go further. Number 5, it's a trinomial. The leading coefficient is 1, so I'm going to go straight to my 2 parentheses. Normally I'd have an x and an x, but that multiplies to x squared, and I need it to multiply to x to the 6th. So instead, I'm going to have x cubed and x cubed. Now I'm looking for 2 numbers that multiply to 15 and add to -8. Those numbers would be -5 and -3. Now this one can't fit the squared pattern because my exponents are 3. So I'll check to see if it fits the cube pattern. It doesn't because I can't take the cube root of 5 or 3. Number 6. All right, it's a trinomial, the leading coefficient of 1. I'm going to go straight to my two parentheses. Normally I'd have an x and an x, but this time I'm going to have x squared and x squared because I need to get it to multiply to 4. Now the two numbers that multiply to positive 48 and negative 19, you may not know immediately, but use your calculator, do a little guess and check. What goes in 48? Try 2, try 3, try 4. Well, you're going to end up that's negative 3 and negative 16. Now I got to see if it factors further. This one over here on the left, I can take the square root of x squared, but not 3. Nothing I can do here. But this one on the right, I can take the square root of x squared and 16. So this one stays the same, x squared minus 3. But this one gets split into 2. Square root of x squared is x, the square root of 16 is 4, one's plus, one's minus, and that's your final answer. So in these problems, you're going to have to be looking for other things when you factor. You may just not factor once. Okay, last thing is trinomials where the leading coefficient is not 1. Those are going to split the middle term. So here the leading coefficient is 3, clearly not 1. Now even though it's a new problem type, we still need to look for the greatest common factor. There isn't one on this first one, so I'm going to go start my process of splitting the middle term. Now, there's other ways to do this. Some people were taught to guess and check. If you can guess and check correctly and you have no problem with it and can do it efficiently, please go ahead and guess and check. If you don't know what that is, or if you have no idea what to do, then I'm going to suggest you split the middle term. So to split the middle term, the first thing I do is take 3 times 21, which is 63. Now I'm looking for two numbers that multiply to 63 and add to 16. Well, those two numbers would be 9 and 7. So I'm going to rewrite this by splitting the middle term. So that's my middle term, and I'm going to split it into 9x and 7x and then 21. Now, at some point, someone would probably ask, does it matter whether I put 9 first or 7? No, your work's going to be a little bit different in the middle, but your final answer will be the same. So you can't put them in the wrong order. Now we're going to factor by grouping. So I'm going to look at the first two. What can I factor out of that? What's the greatest common factor? Well, the greatest common factor is 3x. So I'm left with x plus 3 when I take out the 3x. Whatever sign is in the middle, I copy it straight down. Now I'm going to look for the greatest common factor of these two terms, which is 7. And when I do take out a 7, I get x plus 21 divided by 7 is 3. If you've done it correctly, these parentheses should match. Oh, and if it factors. So I'm going to write one parentheses of what matches. Then I'm going to make a second parentheses of what they split, 3x plus 7. And this right here is my final answer. All right, let's try this again. So first, I'm going to look for a greatest common factor. I don't have one. So I'm going to take 5 times negative 12, and that gives me negative 60. Now I need two numbers that multiply to negative 60 and add to negative 28. Those two numbers would be negative 30 and positive 2. Now I'm going to rewrite this splitting the middle term. So I have 5x squared, and this gets split to negative 30x plus 2 minus 12. Notice that all I changed was the middle term. Now I need to factor by grouping. What can I factor out of the first two terms? 5x. And that leaves me with x minus 6. Ooh, somehow I'm missing an x here. My bad. Okay, whatever sign is in the middle, copy it down. What can I factor out of the next two terms? I can take out a 2. That leaves me with x minus 6. I know that it factored. I've done it correctly because both of these parentheses match. So I'm going to make one parentheses of what it matches and another parentheses of what they split. All right, let's try this again on number 3. On number 3, we're looking first for a greatest common factor. Do we have one? Yes. So we want to take out the greatest common factor first. If you don't take out the greatest common factor, then your final answer will not be completely factored and you'll have more work to do at the end. So I'm going to take out the 2. The other advantage is it makes your numbers a lot smaller and easier to work with. So I'm going to take out the 2, and that leaves me with 2x squared plus 13x plus 15. Now, I still have to split the middle term, but if I had not done this, I would have had to take 4 times 30, which is 120, and look for numbers that multiply to 120 and add to 26. Now I just need to take 2 times 15, which is 30. That is much more manageable than 120. So 2 times 15 gives me 30. Now I need 2 numbers that multiply to 30 and add, whoops, we're in the wrong spot, my bad, and add to 13. Well, those 2 numbers would be 3 and 10. GCF gets a free ride. 2x squared. Split the middle term. So I'm going to have plus 3x plus 10x plus 15. Okay, again, GCF gets a free ride. What can I factor the first 2 terms? Well, I can take out an x. That leaves me with 2x plus 3. Plus, what can I take out of the second 2 terms? Well, I can take out a 5. That leaves me with 2x plus 3. So the 2 comes down, both parentheses match, 2x plus 3, and then I can make a new parentheses of what they split, x plus 5. All right, let's try this again. On number 4, first I'm going to look for a greatest common factor. There's not a number that I can divide into all 3 of these, so I'm going to split the middle term. 3 times 5 is 15. Now I need 2 numbers that multiply to 15 and add to negative 16, which would be negative 15 and negative 1. So now I'm going to rewrite this. I have 3x to the 4th, and then I'm going to split this middle term. So normally I'd write 15x minus x, if I can write, minus 5. But negative 15 and negative x add to negative 16x, not negative 16x squared. And we need it to match, so I'm going to put a squared here. Now if I added these together, that'd give me negative 16. So these are equivalent. If they don't match, it's not going to work. Okay, now factor by grouping. What can I take out of these? I can take out a 3x squared. That leaves me with x squared minus 5. This is a minus. Copy that down. Well, there's nothing I can factor out of the second 2 terms, but I always have to factor out something. So if there's nothing I can take out, I'm going to take out a 1. But I'm really taking out a negative 1, which ends up changing the sign of everything in my parentheses, leaving me with positive x squared plus 5. Okay, so now you're saying the parentheses don't match. We made a mistake. We did make a mistake. I wrote a minus 5 here, but what should it have been? It should have been a plus 5. So if this is a plus 5, when I took out a negative 1, this would really be a minus 1. Whoops. Now, that's unfortunate, but I knew they had to match, so I was able to spot check my work and figure out where I went wrong. Okay, rewrite it. So I get x squared minus 5 times 3x squared minus 1. All right, I know we've got 4 more left. We're just going to do 2 more together so you can have a few more examples, and then we'll be done for today. Well, then you can also see the second video with some extra practice, but done with this set of notes. All right, number 5, there's no greatest common factor, so the first thing I'm going to do is take 4 times 18. So 4 times 18 would be 72. Now I need 2 numbers that multiply to 72 and add to 17, which would be negative 8 and negative 9. I'm going to rewrite this, so I have 4x to the 6th minus, now I got to split the 17, but now I'm going to write negative 8x to the 3rd minus 9x to the 3rd plus 18. All right, look at my first 2 terms. Will anything factor out of that? Yep, 4x to the 3rd. That leaves me with x to the 3rd minus 2. Over here, I can take out a 9, but it's really a negative 9 because that sign comes down. So when I divide, I'm going to get x cubed minus 2. So my parentheses match, so I have x cubed minus 2 and 4x cubed minus 9. Now because, and I should have checked this on the blue one, but I didn't, because they have an x cubed, I got to see if I can factor further, but I can't take the cube root of any of these numbers, so I'm going to stop. Number 6. Number 6, I'm going to do 3 times 8 because there's no greatest common factor. I'm going to do 3 times 8, which is 24. Now I need two numbers that multiply to 24 and add to negative 10, which would be negative 6 and negative 4. So I'm going to rewrite this. I have 3x to the 10th minus, split this into negative 6x to the 5th minus 4x to the 5th plus 8. Factor by grouping. Here I can take out of 3x to the 5th. Leave me with x to the 5th minus 2, minus, because I copy that sign down. Here I can take out a 4, but it's really a negative 4, so it's going to change my sign. So I have x to the 5th minus 2. Rewrite it. Now I can check, but 5 isn't divisible by 2 or 3. Okay, I lied. We're going to do one more. We're going to do number 8. So no greatest common factor. 4 times 9 is 36. Now I need two numbers that multiply to 36 and add to negative 13, which would be negative 4 and negative 9. So now when I rewrite this, I have 4x to the 8. Split this one, so I have negative 4x to the 4th, because remember the exponent's got to match, minus 9x to the 4th plus 9. Okay, out of the first two, factor by grouping, I can take out 4x to the 4, and I'm left with x to the 4th minus 1. Copy down the sign in the middle. Here, I can take out a 9, and that leaves me, it's a negative 9, so I'm left with x to the 4th minus 1. Now I'm going to rewrite this. So I have x to the 4th minus 1 times 4x to the 4th minus 9. All right, now this is when it starts to get exciting. I can take the square root of everything here, so everything is going to fit the pattern. So on this one, square root of x to the 4th is x squared. The square root of 1 is 1. 1's plus, 1's minus. Over here, the square root of 4x to the 4th is 2x squared. The square root of 9 is 3. 1's plus, 1's minus. Now, let's look over here on the right. I can't take the square root of any of the 2 or the 3, so these last two parentheses are not going to go any further. But oh my gosh, look what happens here. This, I can factor to x plus 1i, x minus 1i. Why did I add the I? Because I'm factoring the sum of squares. This one can factor to x plus 1, x minus 1. Why did I not add the I? Because this is the difference of squares. This is a minus. This one can't factor any further. And so we are done. I know it looks painful and it's a lot of work, but we're just going to keep thinking about the patterns and doing the best we can.